This is fundamental problem 14. The dragster starts from rest and has a velocity described by the graph. Construct the position versus time graph during the time interval from 0 to 15 seconds. Also, determine the total distance traveled during this time interval. If they ask me to construct the graph, or if they ask you to construct the graph for homework, I'm going to be satisfied if you just sketch the graph. If I want you to actually find the position as a function of time, I will ask you to do that. Okay, so in this section, when they ask you to construct the graph, you don't need to find the equation unless they specifically ask you to do that. Okay, so thinking back to Physics 161, if you have a velocity versus time graph and you want the position versus time graph, you'd look at the area underneath the curve, or I would find it's easier if you ask yourself, what does the slope of the position versus time graph have to be in order to give me this velocity versus time graph? So velocity is positive from here to here, so the slope of the position versus time graph should be positive, but the slope starts off at 0 because the velocity is initially 0, and they told me that the dragster starts from rest, so I know that the velocity is initially 0, but they should have told me what the initial position is, or I could choose a coordinate system such that the initial position of the dragster is 0. So we're going to let the initial position be equal to 0. So we have a slope of 0 here, and I'm going to say the initial position is 0 also. The graph that we're going to draw could be shifted up or down, and it would still be a solution because they didn't tell us what the initial position is. So the slope here is initially 0. The slope is positive and becoming more positive, so that looks like this until we get to 5. This is where the slope is at its maximum value. After this, the slope goes back to 0, but not as quickly, so something like that. And then at 15, we should have a slope of 0. Okay, because they gave you the equations here, you could integrate those equations with respect to time to find what the position is as a function of time. For this first piece here, it's not that hard to do. It would just be 15 times t squared. For the next piece of the graph, I'm not going to do it unless they specifically ask me to do it. So we have the sketch of the graph, and we're going to be happy with that. They also want to find the total distance traveled. The total distance traveled would be where you are at this point here. So if you did find that equation, then you could use that to find where you are here. In this case, you can tell from looking at the graph, you didn't turn around at all. And so the total distance traveled is going to be the same as the displacement. The displacement is the area under the curve here. But we can find that easily without doing any calculus, just by saying, well, we have, let's say, 2 triangles here. Okay, the first triangle has a base of 5 seconds. Times 150 for the height, meters per second. It's a triangle, so I should have a 1/2 in there also. I'll have to stick it in at the end. So that's this area here, plus then we have another triangle. This time I'll remember the 1/2. And the base from there to there, that would be 10 seconds times the height of 150 meters per second. 5 seconds times 150 meters per second times 1/2 is 375 meters. 100, that looks like a 105. 10 seconds times 150 meters per second times 1/2 is 750 meters. And 375 plus 750 is 1,125 meters, and this area is the total distance traveled. So that concludes fundamental problem 14. There was a homework problem. Let me just go back and check. So it's problem 40, which is a homework problem where I tell you in the homework assignments file, when it asks you to draw the graphs, that's all I want you to do. I don't want you to do any calculations for this problem. You can if you want to, but all I'm really interested in is what the graphs look like. Okay?